All right. Hello and welcome everybody to another physics video lecture. Today we are going to start talking about circuits. And we're going to start talking about series circuits, okay? So the first place to start here is to kind of understand what a circuit is and what the two types of circuits are. Now, last class we talked about Ohm's law and we learned about voltage, current, and resistance. Just real quick recap. Voltage is how many electrons are moving, okay? Current is how fast those electrons are moving, and resistance is anything that slows the electrons down. Should also recap that electricity is electrons moving, all right? So today we're gonna see how electricity moves. And electricity moves in something called a circuit. The word circuit should kind of be a hint. Look at the first four letters, and you see something that looks very much like the word circle. And this is on purpose. If you look, electricity always has to flow, okay, from the negative end of the battery to the positive end of the battery. Remember, the negative end of a battery is only negative because it's got a ton of electrons, and the positive end is positive because it has very few electrons. If you put a conductor, which is any piece of metal, connecting the negative and the positive end of a battery, those electrons will run out of the negative end to the positive end, thus creating electrical flow through the wire, and then you can run it through whatever you want, whether it be your phone or a light bulb or your TV, your toaster, whatever you're trying to get electricity to. That's the basis of how it works. And there's two main types of circuits. The one we're going to look at today is called a series circuit, and a series circuit is called a series because it is one continuous loop, okay? So what I mean by that is if you put your finger or your pencil at the negative end of the battery, if you follow the electricity through everything, you will never pick your finger up. It's just one big circle, okay? Next class, we're going to talk about parallel circuits, but they are called parallel circuits because they're not one big continuous series. They split into many circuits, okay? You see it right here. Here you have one, and instead of going through both light bulbs and then back to the battery, it splits. And now you have a fork where you have one circuit here and one circuit here. There are advantages and disadvantages to both kinds of circuits. Series circuits are, they're easier to make, they are cheaper to make, but the downside here is that if anything in this circuit goes down, if one of these light bulbs dies, it literally cuts the circuit and power goes out, which is a bummer, right? Parallel circuits are much better because even if this light bulb dies here, there's still a full continuous circuit that allows electricity to go to this light bulb. If you have cheap, old Christmas lights in your house, they're probably wired in series, meaning if one of those light bulbs dies, all the light bulbs die. You have to find the one and replace it. If you've ever done that, not fun. Whereas like our houses and most modern things are wired in parallel. All right, so again, series circuits, what do we know? The current in a series flows in only one path. It is a continuous single loop. It is what we call a closed circuit, and it's closed because again, it doesn't split into other circuits. Now, we need to understand a few things about series circuits, and that is what happens with the voltage, what happens with the current, and what happens with the resistance, okay? The current in a series circuit is the same everywhere in the circuit. And this is, if you want to highlight the next three things, they're probably the most important. The current is the same everywhere in a series circuit, all right? The voltage in a series circuit is broken down, and every light bulb or every resistor in that circuit gets a little piece of that voltage, okay? So we say that the voltage drops over every one of the resistors, okay? I'll go over this when we actually look at the resistors, okay? But the current is the same everywhere, and the voltage drops over each resistor. When it comes to the resistance in the series circuit is super easy. All you gotta do is just add up all the resistors, and that gives you your total resistance, okay? So again, here's just a comparison between the two. Here, to find the total resistance, we just add up all the resistors. So if this light bulb was 1 ohm and this light bulb was 1 ohm. 1 plus 1 would give us a total of 2 ohms of resistance. We see that we have a constant current, so the current is the same everywhere, and the voltage gets used up. So like, let's say that this was a 2-volt battery. This light bulb would get 1 volt, this light bulb would get 1 volt, and then it goes back and it juices itself back up. Okay, we'll get to parallel circuits next class. So 2 things that you need to understand are these circuit symbols. Here you see a battery symbol. It's a big line and a little line. The big line is the positive end, the little line is the negative end. Sometimes you see more than 1 battery. This is what 2 batteries looks like. And then whenever you see this squiggly line, this is always a resistor. Sometimes we always use light bulbs just because they're the easiest things. They're the simplest resistors, and you can see when they turn on, you can see how bright they are. So they're really useful. Sometimes you'll draw a light bulb, but these squiggly lines, these little jagged lines, these are always going to be resistors. All right. Now, like I said, just to give you an example here, to calculate, the current. What did I say? The current? I gotta change this. I'm gonna change that before I give it to you guys. To calculate the resistance, the total resistance, all you have to do is just add up the resistances. Okay. So again, here we have our battery. Here are resistors 1, 2, and 3. They're the squiggly lines. Our first resistor is 100 ohms. Our second resistor is 300 ohms. Our last resistor is 50 ohms. If I wanted to find the total resistance, I'd add them up. 100 plus 300 plus 50. And that gives me a total resistance, or what is sometimes called an equivalent resistance. Equivalent just means equal, of 450 ohms. I should have put this one first. So here is a series circuit in its entirety. Okay, again, here's your battery. Okay, this is the battery. In fact, this is technically 2 batteries right here, but they have a total of 9 volts. If you had if both of these were 9 volts, all you do is you just add up your batteries. So it's really simple to find your total voltage. Just add up the batteries. Here are your resistors. Okay, we usually call them R1, R2, R3, and we always go clockwise whenever we're looking at a circuit. So you come out of the battery, the first resistor eats up a little bit of the voltage, the second one eats a little more, the third one eats more, and then it goes back to the battery to do it all over again. Now, we're about to learn one of the coolest tricks that we learn all year. It's one of my favorite things. I love talking about circuits, but in order to understand this, we got to do a little rearrangement of our electrical, or Ohm's law, our electrical equation. Here, Ohm's law tells us that current equals voltage divided by resistance, right? Now, if I want to move the R from the bottom of this equation, I would multiply both sides by R, and R divided by R would cancel, and now I get voltage equals current times resistance. See that? These 2 equations are exactly the same. I just rearranged them. And you will see that there is a very, very good reason why we want to see this. VIR. V equals I times R. Voltage equals current times resistance. Okay? And here's why we did that. It's so that we can make VIR charts. Voltage, current, resistance charts. And yes, these are now going to be your new best friend in physics. Long story short, whenever you're doing circuit calculations, they can be very long. Sometimes they can have 4, 5, 6 different steps. It can sometimes be tricky to tell which step you do first. And using these VIR charts makes all of this so much easier. It actually makes it kind of fun and turns it into this puzzle, almost like a Sudoku. Okay? So let me break down the chart for you guys. All right? So at the top, the first thing you do is you want to have a column for each attribute. So one for voltage, one for current, one for resistance. And you want them in that order, VIR. Why? Because voltage equals current times resistance. And this allows us to do some pretty cool math. In this column, you're going to have, in the rows, you're going to have a row for each resistor. So if you have 3 resistors, like we just saw, you have an R1, an R2, and R3. And at the very bottom, you have your total, where you put your total voltage, your total current, and your total resistance for the entire circuit, okay? Now this may sound weird, okay? So let me show you how this works, and I'm gonna go through a couple examples to show you how easy it is to use this to solve these problems. Okay, so here is our first series circuit. Check always, number one, that we know that it's a series circuit. Okay, the loop comes out of the battery and it goes through each resistor all in one continuous loop. It never splits anywhere along the line. It's just one big circuit, okay? So, how do we do this? Well, like everything else, we start by filling in everything that we know. And I always like to start at the battery. Here we have two batteries, but it gives me the total voltage. It just tells me my total voltage is always the battery. So this is 9 volts. So underneath voltage total, I write 9 volts. I already know that. I also know each one of my resistances, right? My first resistor is 3 kiloohms. I'm just gonna use, we're gonna pretend like these are just regular ohms just to make it easier, okay? This one is 10 ohms. I know it says kiloohms, just ignore that. And this one is 5 ohms. Okay, so this is everything that we are given. And with just this, we are going to be able to fill out the entire chart. How do we do it? This is where the fun starts. So this is almost like a puzzle or a game where you just kind of start filling in everything you know. So if you remember, in a series circuit, the first thing we're going to do is, if you know all the resistances, the total resistance is you just add up all your resistors, right? So we have 3 plus 10 is 13. 13 plus 5 is, got that? 18 ohms. So now I know my total resistance, okay? And now here is where this chart becomes the best thing ever. Remember earlier, we found out that voltage equals current times resistance, okay? So on any one of your rows, if you know 2 numbers, you can very easily find the third, all right? So how do we do this? Well, I know that voltage equals current times resistance. So here in this last row, I know 9 equals the total current times 18, right? Well, we just have to do some basic algebra. We're trying to get this I by itself. So this is multiplication. So I divide. Whatever I do to this side, I do to this side. 18 divided by 18 is 1. And 9 divided by 18 gives me my total current, which is looks like a snake. 0.5 amps. Now, when you start getting good at this, you can start just looking at it and saying, well, if 18 times what is equal to 9? And the correct answer here is 18 times 0.5 is 9. Again, there's no shame in doing the algebra. It's pretty straightforward. Now, where does this get us? Well, if you think back to that original chart, we know that the current is the same everywhere in a series circuit. Aha! So if my total current is 0.5, that means my current at the first resistor is 0.5 amps, the second resistor is 0.5 amps, and the last resistor is 0.5 amps. The current is the same throughout. It doesn't get chewed up, it doesn't get used up. It's the same at every one of these resistors. What's the current here? 0.5 amps. What's the current here? 0.5 amps. What's the current here? 0.5 amps. It's the same everywhere, right? And now, hopefully you're seeing it, we know that the voltage that each resistor uses is going to be different, okay? The bigger the resistor, the different amount of voltage that it uses up. But again, we know that voltage equals current times resistance. So if I know the resistance of the resistor and the current that it uses, I can pretty easily find the voltage. All I got to do now is multiply these two. 3 times 0.5 is 1.5 volts. Again, you can always use your calculator. I just know that, okay? 10 times 0.5 is 5 volts. And 5 times 0.5 is 2.5 volts. And there's everything that you would ever want to know about this problem, okay? Look at what we see. We see that the bigger the resistor, the more voltage it eats up, right? It's probably because it's going to be a brighter light bulb, okay? This first resistor is only 3 ohms, so it only uses 1.5 volts. The next resistor is 10 ohms, so it uses 5 volts. Now you can always double check your work, okay? Go down here, all the voltages have to add up to 9 volts. The first one's 1.5. 1.5 plus 5 is 6.5. 6.5 plus 2.5 is 9. So just another way of seeing this, when the current comes out, when the voltage, when those electrons come out of the battery, there's 9 volts. That first resistor eats up 1.5 volts. So it goes, so coming out of this resistor, we now have 7.5 volts. This next resistor eats up 5 more volts. So 7.5 minus 5 is 2.5 volts. And that goes into the last resistor, and the last resistor eats up those 2.5 volts. There's what we call a voltage drop over every one of the resistors. And by the time that current gets back to the battery, okay, it's all been used up, but guess what? The battery charges it back up again, and you start the same cycle over and over. This chart allows us to double check everything. For a series circuit, we got to make sure our current is the same all the way down. We have to make sure our resistances all add up to our total resistance. We got to make sure our voltages add up to our total voltage. And you got to multiply each row to make sure that they all multiply out. 3 times 0.5 is 1.5, 10 times 0.5 is 5. All of these add up. Here's everything that you know. If a question says, what is the voltage drop at the third resistor? If you just quickly make this chart, you go third resistor, voltage, 2.5. How much current does the second resistor draw? Second resistor draws 5 amps of current. What's the total resistance? Total resistance is 18. Do you see how useful that is? It's very useful. Let's do another one so you guys can see how awesome this is. All right, this one looks a little different, but we always start the same way. We have 1, 2, 3 resistors. So I have 1, 2, 3 resistors and a total. We write down what we know. I know my total voltage coming out of the battery is 40 amps, or excuse me, 40 volts. I do not know what my first resistor is, but I know my second resistor uses 10 volts. Does everybody see that? See how it says 10V? So my second resistor uses 10 volts. And I know that my third resistor, I know 2 things about the third resistor. The third resistor uses 20 volts, and it has 10 ohms. So resistor 3 is 10 ohms. Oh, look at this. It really is like a Sudoku puzzle. So now we're going to figure out everything we know. So there's lots of different ways you can go about this. I like to start here on this column. I know my voltages have to add up. So here I have 10 plus 20, that's 30 volts. If my total voltage is 40, that means in order for these to add up to 40, this first resistor has to use 10 volts. 10 plus 10 is 20, 20 plus 20 is 40. Awesome. Now I can go across my column or my rows. I could have done this first, it's fine. And I know that voltage equals current times resistance. So here I have 10 times blank equals 20. Well, what times 10 equals 20? Well, 2 does. Ba-boom. I know since this is a series circuit, I know the current is the same everywhere. I like to think about this because the I is one continuous line. It's one line, okay? So it doesn't split, so that's how I know that the current is the same everywhere. So if my current at the third resistor is 2 amps, it is 2 amps everywhere. And now, wherever I know 2 numbers in a row, I can find the third. What times 2 equals 10? Well, 5 does. What times 2 equals 10? Well, 5 does. Very good. 5 times 2 is 10, 5 times 2 is 10, 10 times 2 is 20, and so our last one here, and we can double check this, to find our total resistance, we just add these up, 5 plus 5 plus 10, 5 plus 5 is 20, sorry, 5 plus 5 is 10. 10 plus 10 is 20. And if we go across here, 20 times 2 is 40. And again, we can very quickly answer any question that we want about this circuit. Isn't this fun? Let's do another one. All right. Okay. Again, start off with what we know. I know my battery is 75 volts. Oh, I only have 2 resistors this time, R1, R2, so that's different. My total voltage is 75 volts. That's what the battery is. I know that the resistance of my first resistor is 10 ohms. I know that my current in my first resistor is 5 amps. And I know that the resistance, or the voltage at my second resistor is 25 V. So it's good to pay attention to those units. So my second resistor is 25 volts. Now, there's a bunch of different ways you can go about doing this. Let's do this row that has 2 things. We know that voltage equals current times resistance. So this resistance has to be 10 times 5, which is 50 volts. And we have to make sure that our resistors add up, or that our voltages add up to the total voltage. 50 plus 25 is 75. I should also say, if you want to pause this and do this one on your own, you should. See if you get the same numbers I do. Pause. All right, you got it? Cool. Now, where do we go from here? Well, remember, the current is the same everywhere. So if I have 5 amps of current at the first resistor, I have 5 amps of current at the second resistor, and 5 amps of current at the third resistor. Okay? Now, wherever I have 2 numbers in a row, I can fill that out. What times 5 is 25? Well, 25 divided by 5 gives me 5. Okay? And now if I add up my resistors, 10 plus 5 gives me my total resistance, which is 15. And you can double check yourself because 15 times 5 equals 75. Oh, I love you so much, VIR chart. Do you see how much of a lifesaver this is? Hey, what's the resistance of the second resistor? Second resistor, 5 ohms. How much current's at the first resistor? First resistor has 5 amps of current. What's the voltage of the second resistor? 25 volts. What's the voltage drop of the first resistor? 50 volts. Just another name for it. Do you see that? So beautiful, so useful. You want to do one more? Let's do one more. All right. Here we go. So this one's a little weird. It doesn't give us the battery. We don't know what the total voltage is. So let's write down what we know. I know that my first resistor is 5 ohms. I know that my second resistor is 15 ohms. And I know that my current coming out of my second resistor is 5 amps. All right, these are the only 3 numbers we get, but we can do a lot of stuff with it, right? First things first, we know that you add up the resistances in a series circuit. 5 plus 15 is 20. Oh, again, pause this. See if you can do it on your own. Pause. Do you have your chart filled out? Awesome. Okay, next thing we know that our current is the same everywhere in a series circuit. So this is 5 amps and this is 5 amps. Our total is the same as it is everywhere else. And again, voltage equals current times resistance. 5 times 5 is 25 volts. 15 times 5 is 75 volts. 20 times 5 is 100 volts. And we double check. 25 plus 75 added up to our total 100. Again, each resistor eats up some of the voltage. This resistor is only 5 ohms, so it only eats up 25 of those volts, whereas this resistor is much bigger. It's 15 ohms, so it eats up 75 of the 100 volts. And that's it. If you can make a VIR chart and remember this couple things I told you, number 1, a series circuit is a continuous loop. Number 2, to find the total resistance, you just add up all the resistors. Number 3, the current is the same everywhere in a series circuit. Remember that single line of current helps me remember because it's one single loop. And the voltages add up to the total voltage, okay? Each resistor eats up a little bit of that voltage, so there's a voltage drop there. And the last thing is if one of these resistors goes dead, you're pretty much cutting the cable, and that kills the entire circuit. Because remember, the two ends of the battery have to be physically connected with a wire. And that's it. All right, guys, we will continue this by talking about parallel circuits next class. Go through these, work through them yourselves, and on any question that you have on your DOL, get a piece of paper, make yourself a chart, and it'll be a breeze. All right, guys, have a beautiful day. Email me if you have any questions or find me on Zoom After School for Tutoring.